Valve clearance adjustment is a normal maintenance procedure for Briggs & Stratton engines. Although not required as often as other procedures like changing oil and air filter elements, it is no less important to the proper operation of the engine. The overhead valve engine valve train consists of the cam gear, tappets, push rods, rockers, valve and spring assemblies, stem caps, valve guides, and valve seats. The tappets, push rods, and rockers transfer motion from the cam gear lobes to the valve stems, opening and closing the valves. Because this is a mechanical event carried out over some distance and through a variety of temperature variations, an adjustment is necessary to set the distance between these moving parts. Too tight and the valves can be held open when at operating temperature. Too loose and the compression release can be made ineffective, causing difficulty in starting and bent push rods. According to many consumer owner's operators manuals, valve clearance should be checked annually, with a footnote suggesting this is not required unless engine performance problems are noted. For commercial engines that run long hours under heavy loads, check valve clearance every 100 to 250 hours and adjust as necessary. Valve clearance adjustments on overhead valve engines are relatively easy to do if you pay attention to certain details. And of course, practice always hones your skill. Always start with a cold engine. Remove the spark plug and valve cover. The clearance adjustment is one of two types and will involve the rocker arms. The first type is a ball and socket type of arrangement where the outer hex is the adjuster and an Allen or Torx set screw or nut is used to lock the setting in position. The adjustment process raises or lowers the rocker, which changes the clearance. This system is often used on mid-range to smaller displacement engines. The second type features an adjustment screw and a lock nut on the end of the rocker arm. The center screw is the adjuster and the outer hex the lock nut. The screw on these is often a Torx socket set screw. This approach directly opens or closes the gap between the valve stem and the rocker. To get started, gather the tools necessary to loosen the set screw or lock nut and turn the adjuster. Locate the clearance specifications on the power portal, a repair manual or owner's operator's manual, and a thin but sturdy rod like a pencil or soda straw about 10 inches long. This rod will be used as a gauge. Valve clearances on all single and twin-cylinder Briggs & Stratton engines are set with the engine positioned so that the piston is 1/4 inch past top dead center at the beginning of the power stroke. Another way used to describe this position is 1/4 inch past top dead center at the end of the compression stroke. To ready the engine for adjustment, turn the engine over in a clockwise direction from the flywheel side until the piston is at top dead center with both valves closed. An easy way to get close to top dead center on Briggs & Stratton 4-cycle engines is to line up the PTO keyway with the center line of the cylinder bore. Then insert the pencil or screwdriver gauge into the spark plug hole and rock the crankshaft back and forth until the gauge indicates the piston is at top dead center. To check that you're at top dead center at the end of the compression stroke, both pushrod ends should be level with each other. If one is higher than the other, rotate the crankshaft clockwise 360 degrees. If you can't see the pushrod ends, wiggle the rockers. Both rockers loose means you're in the right spot. One loose and one tight, rotate the crankshaft 360 degrees. The gauge should be in the spark plug hole, resting on the top of the piston. Slowly rotate the flywheel clockwise until the gauge drops 1/4 inch into the cylinder bore. The engine is now set up to check or adjust valve clearance for both the intake and exhaust valves, so don't allow the crankshaft to move. Valve clearance may not need to be adjusted, so check the clearance first. If you don't have one, get a stepped feeler gauge. This is a feeler gauge set that functions as a go-no-go gauge and can make the job a whole lot easier. Each blade will measure 2 different sizes. This one, for example, is 4/1000 of an inch thick for the first 1/2 inch or so, and 6/1000 of an inch thick for the rest of the blade. If the end of the blade easily slides in and then it catches when it meets the 6/1000th inch change, your measurement is 5/1000ths of an inch. We'll assume the valve clearances on this engine need to be adjusted. Let's start with the intake valve. This 130G32 engine has a ball and socket type adjuster with a large 14mm adjustment nut and a 10mm lock nut. Hold the adjuster nut with a wrench, loosen the lock nut, back it out about a half turn, and then back the adjuster out about a half turn also. Do not loosen the lock nut without holding the adjuster nut with a wrench. You may shear the stud off or break the adjuster. Choose the feeler gauge blade to fit the valve clearance specifications for this engine. Slide the 4/1000ths to 6/1000ths inch gauge between the cap on the valve stem and the rocker arm. When you tighten down the lock nut, the setting will tighten up. Keep the 14mm wrench on the adjuster nut while you check the clearance at the valve. It is often too tight. If so, you can quickly loosen the 10mm nut, back off the 14mm nut a bit, lightly tighten down the 10mm and check clearance again. It may take 1 or 2 of these cycles to get the right clearance, but it goes quickly. The reason we may not get the correct clearance the first time is that when the lock nut is tightened, it forces the adjuster down against the base of the threads on the stud. This is usually about 1/1000th to 1.5/1000ths of an inch, as you can see in this demonstration. This is a demonstration of what occurs when we tighten down the lock nut on the top. The way this is set up is, this is the ball and socket adjuster, and it's pressed into this arm that you see going across the top. On top of that, you'll see a jam nut. We're going to tighten that up against the adjuster, and you'll see the change it makes simply from compressing the adjuster down and against the base of the threads on the stud. Keep an eye on the gauge. Now we tighten up the jam nut at the top and see the change that's occurred just from snugging the nut down. Once the clearance is correct and the lock nut snugged down, it won't change much, if at all, when the lock nut is torqued, as long as the tightening process does not turn the adjuster. The other type of valve adjustment mechanism features a threaded hole in the end of the rocker arm. An adjustment screw threads into the hole, and valve clearance is adjusted by turning the screw in or out. The clearance is locked in by a lock nut threaded onto the screw. This is a jam nut arrangement where the nut jams against the rocker surface, binding the screw in place. The engine we're working on is a cold 202-332 Intech Pro engine. To start, remove the valve cover and spark plug. Turn the engine over clockwise as viewed from the flywheel side until the PTO keyway is in line with the center line of the cylinder you'll be adjusting. Check to see if both push rods are level and both valves are closed. Find top dead center with a gauge in the spark plug hole. Turn the engine clockwise from the rewind side until the gauge drops 1/4 inch past the spark plug gasket surface. Check clearances first. Take note of clearances that are way out of specification to aid in troubleshooting. There's a reason for this that may reveal other problems. We'll assume the valve clearances on this engine need to be adjusted. Let's start with the exhaust valve. Loosen the lock nut and back it off about 1/2 a turn. Slide the 4/1000ths to 6/1000ths feeler gauge blade between the valve stem and the rocker. If clearance is too wide or too tight, rotate the adjuster screw appropriately and recheck. The adjustment screw has a metric thread, M10 by 1.0, so if you do the math, each quarter turn is 10/1000ths of an inch. You shouldn't have to move it much. When the 4/1000ths inch part of the gauge enters easily, and the gauge sticks at the break between the 4/1000ths and 6/1000ths inch separation, you are where you need to be. Hold the adjustment screw steady and snug down the lock nut. Once the lock nut is snug on this system, it shouldn't change the clearance when you go from snug to torqued. To double check your work, pull the engine through a cycle or two and recheck the clearance. Here are a couple of things to consider. Valve clearances that are too close will only get closer when hot. This is likely to become a negative clearance where the valve is not allowed to close at all. The engine will display performance problems, stop altogether in extreme cases, or not restart hot in others. Valve clearances that are too wide will make an engine hard to start because they will be harder to pull over due to the high compression. The wider they get, the more the compression release is taken out of the picture. At 20 thousandths of an inch plus clearance, the compression release is deactivated on many engines. A compression test can be as high as 140 psi. The engine will be obviously harder to pull over. Evidence you may see from valve clearance problems includes clearance too tight on the intake can cause idle stability and quality problems. Clearance too tight on the exhaust can cause power and performance issues and burned exhaust valves. Clearance too loose on the exhaust can cause serious safety concerns due to kickback and cause starting difficulties.